Final word, I forgot it, while we're talking about the various types of engines, let's have a look at typical speeds they operate at. Mach is the speed of sound. Mach 1 is the speed of sound, and it's about 1200 kilometres an hour. Propeller internal combustion engines typically work 300 to 400 kilometres an hour maximum. All these speeds are kilometres an hour. So a propeller aircraft normally works at 300 to 400. I googled the cruising speed of a Cessna, it said it was 270. A turboprop aircraft...
Here's what I found.
Gotta love Google. I googled the top speed of a Bombardier aircraft, a turboprop aircraft, it said 600. It's got to be below 750 kilometres an hour with a propeller, because above that speed you get problems with the tip of the propeller being at maximum speed, getting close to the speed of sound. Once you get shock waves from hitting the speed of sound at the tip of the propeller, you tend to kind of lose thrust and lose your propeller as it breaks apart. So, typically propeller aircraft 300, 400 for a combustion engine, 600 kilometres for a turboprop. A turbofan, your standard jet engine that's used in commercial jet airliners, works best at about 370 to 2,500 kilometres an hour. But as you know, it also works at takeoff, so it works at zero and slowly builds its way up, but it's most efficient in that range. Turbojets, military aircraft, where they don't care about bypass air, all they care about is maximum power. Typically work around about 1,500 to 4,000 kilometres an hour, from about Mach 1 and a bit above to about Mach 3. Ramjets, we're going to cover. Ramjets are rocket engines, along missile engines, not rockets. Ramjets are missile engines, 3,500 to 6,000 kilometres an hour. Supersonic combustion ramjets work at intensely high speeds. Mach 4 and above. Mach 3, Mach 4 and above. They're not commercialised, they have lots of problems, they're highly dangerous. I had earlier on a list of the various air pressures at altitude. What I didn't mention as critical is why would you want to fly a plane when the air pressure outside is 30 kilopascals, 20 kilopascals? Why would you want to fly a plane so high up in the atmosphere? The answer is simple. There's less air, so there's less drag, which means you're more fuel efficient. The higher up you fly, the less air is induced and the lower the drag. The less air is disturbed. And the lower the induced drag, the lower the formed drag, the lower the parasitic drag. By operating at air of a lower density, you get better fuel efficiency.